Hello, this is Christian Galindo with my ENME 351 lab number 4 report. First, we'll run through the Arduino code for the report. First, I set up my sampling frequency variable to initialize it up here. Set the baud rate at 115,200 for processing. Then I incorporate my delay using the while loop and the time millis. Going to read the potentiometer with the variable potent and read the nscope with the variable nscope. That will also be printed to the processing window. So in order to go about finding the correct frequencies to output on the processing window, I set up 4 different regions, split up into the maximum analog output, 1023 divided by 4. So between 0 and a fourth of that is 100, between a fourth and a half is 142, between a half and 3/4 is 200, and between 3/4 and the full voltage is 500. And here's the bottom loop for the delay. Here we have the sine waves for f equals 75 Hz. Top left we have 100 for fs. Top right is 142. Bottom left is 200. Bottom right is 500. That will be the same setup for all of the different frequencies. So on top right, you'll see we have a frequency of about 126 Hz. Yesterday, I was able to get that frequency to 142. However, today I cannot, but I did perform all my calculations with 142 as desired and actual, and that programming can be seen in my code to make it 142. Nevertheless, for 75 Hz, we have aliasing at 100 and 142 Hz, as well as 200 Hz, but we get a cleaner slab wave at around 500 Hz. Here are the diagrams for 100 Hz. We see we have a sine wave at around 100 Hz here. We see aliasing at 142 in the top right, aliasing at 200 in the bottom left, and aliasing at 500 in the bottom right. Now with the frequency of 215 Hz, we get aliasing at 100 and 142 Hz. We get more of a cleaner sine wave around 200 Hz, and then aliasing again at around 500 Hz. Now we'll get the 300 Hz sine waves. So we have aliasing around 100 Hz. We see a cleaner sine wave of 142, since we get a Nyquist frequency of 150, and those are pretty close. And then we see more aliasing around 200 Hz and 500 Hz as well.
Here's my completed table for all the different frequencies. For 100, 142, and 200 Hz, I was able to get an output of exactly that frequency. For 500, I was able to get an output of roughly 494 Hz. So, in order to solve for all the aliasing frequencies, I use folding diagrams, which can be seen from all the different pages of the work right here.
This is the triangle wave for exercise 2. We can see that it's set to 10 Hz as a frequency on the nscope. The processing window also outputs a triangle wave, as seen here. The sample rate is about 500 Hz, as seen in the bottom left. So the signal is aliasing at about 10 Hz, also seen around here in the bottom left. With a maximum voltage of roughly 5, you can see that one sample is output every other peak. However, just like the nscope, the voltage maximum is about 4.75 volts. Now changing the input from A1 to P1, we see we get a square wave on the nscope, as well as on the processing window. So look at the square wave, the frequency is exponentially getting smaller, so this frequency approaches 0 at some point. The peaks from the sine wave can be sampled onto the square wave, so this can be seen by the curly lines on the horizontal edges on the square wave on top and on bottom.